Dear second prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Mahmud with you today to introduce a new mathematics lesson. Today, inshallah, we have unit 2 in the geometry. Okay, this lesson related to the triangle and the inequality of triangle and comparing the difference between two sides and the difference between two angles. Let's start the lesson. First, I'm going to explain the concepts of the inequality. Okay, for example, I have triangle like this, and this triangle is called ABC. Okay, now I have, as you see, I have three different sides and three different angles. For example, if the lengths of the sides are 5, 12, and 8, and the length and the measures of the angle, okay, are as we see A, B, and C. By comparing between AC and AB, we see that AC greater than AB in measure, in length, and AB and BC, we see that AB is greater than BC. Now, if the angles are 30, 40, and 110, to compare between the angles, we see that the greatest angle here is angle B, and the next angle C, so B greater than C, and angle C is greater than angle A. This is the order of angles A, ABC, and the orders of the sides AB, BC, and AC. Okay, by looking carefully, if I compared between angle B and angle C. Here angle B is greater than angle C, okay? Here angle B is opposite to this side 12. And the angle C opposite to this side 8. Okay? So the bigger angle opposite to the bigger side in length. And the smaller angle opposite to the smaller side in length. Again, the bigger angle opposite to the bigger side and the smaller angle opposite to the smaller angle. This is the relation related to this unit. Okay, the big side opposite to the big angle and the small side opposite to the small angle and and so on. Or by another meaning, the smallest side opposite to the smallest angle, the middle side opposite to the middle angle, the greatest side opposite to the greatest angle. So always there is a relation between the big side as the angle and the side, the big opposite to the big, and the small opposite to the small. Okay, now comparing the measures of the angles of the triangle. Okay, for example, if I have side like this equal 10 centimeters and another side equal 4 centimeters. Now by comparing between the two sides, we see that 10 is greater than 4. Okay, and if I have angle here B equal 110 degrees and angle A equal 30 degrees. Okay, so by looking carefully, the bigger side opposite to the bigger angle and the smaller side opposite to the smaller angle. Okay, and this is the relation that I need to explain. As you see, the bigger side opposite to the bigger angle and the smaller side opposite to the smaller angle, as you see. Okay, so in the triangle, if two sides are unequal in length, then the longer side is opposite to the angle of greater, which is greater in measure. Okay, now the third case, the smallest side opposite to the smallest angle, and so on. Okay, in a triangle, the longest side in length is opposite to the greatest angle in measure, while the shortest side in length is opposite to the smallest angle in measure. This is what I said, the biggest opposite to the biggest, the smallest opposite to the smallest, and so on. Okay, now let's compare the lengths of the sides of triangle. If we have two sides like this, 10 and 4, okay, and the angles like this, 110 and 30. So In a triangle, if two angles are unequal in measure, then the greater angle in measure is opposite to side greater in length than the opposite to the angle smaller in measure. This is what I explained before. Okay, and the longest side opposite to the greatest angle, and so on. The greatest angle in measure is opposite to the longest side, okay, in a triangle, and the smallest angle in measure is opposite to the shortest side. Okay, in this example, I see here now ABC triangle, okay, in which measure angle AB greater than BC greater than CA, as we see. Okay, here AB greater than BC greater than CA. He needs to prove that C greater than A greater than B. Okay, now I'm going to divide them into two groups. I'm going to compare between AB and BC, and okay, here AB side is greater than BC side. AB is opposite to angle C, and BC is opposite to angle A, so angle C is greater than angle A, as we see. Okay, this is number one. Number two, BC and CA. BC and CA. BC is greater than CA. BC is opposite to angle A, and CA opposite to angle B. So angle A is greater than angle B. Okay, this is number two. From 1 and 2, we get that measure angle C greater than measure angle A greater than measure angle B. This is a very easy proof, as we see. Another example, ABCD quadrilateral, in which AB equal 5 centimeters, BC equal 2, CD equal 3, DA equal 4. Prove that angle C or DCB greater than angle DAB. Okay. First, I need to divide the shape into two triangles because the theorems that I studied before related only to the triangles. Okay. By looking to the first triangle, ADC. Okay. In triangle ADC, here this is 4 and this is 3. The bigger side opposite to the bigger angle, and the smaller side opposite to the smaller angle. So angle DCA greater than angle DAC. This is number one. AD equal 4 and CD equal 3. So AD greater than CD, as I said before, and angle ACD greater than angle CAD, as I explained. Number two, by looking to the lower triangle, this is 5 and this is 2. The side 5 opposite to the greater angle, and the side 2 opposite to the smaller angle. So angle BCD greater than BAC. Okay, this is number 2. ABC triangle. Since AB greater than CB, therefore measure angle ACB greater than measure angle CAB. Here, by looking to angle C, the upper part is big, the lower part is big. Angle A, the upper part is small, the lower part is small. So angle C formed from big plus big, angle A formed from small plus small. So angle C greater than angle A. To say that this in the proof, so I'm going to add 1 and 2 together to get angle C and angle A by adding 1 and 2. So DCB greater than DAB. Okay, now another example. In this example, he gave me AD parallel to BC, as we see. Measure angle CAD equal 35 degrees. Measure angle DAE equal 75 degrees. Okay, so I need what? I need to prove that AC greater than AB. AC greater than AB. It's a very easy question. Here I'm going to reflect 35 from here to here. So angle C equal 35. This is alternate relation. And I'm going to reflect 75 from here to here. This is corresponding relation. By looking carefully, AC is opposite to 75 and AB is opposite to 35, it's easy to prove that AC is greater than AB. Again, AD parallel to BC, therefore measure angle B equal measure angle EAD equal 75. So this angle equals 75 corresponding, and measure angle ACB equal to measure of angle DAC equal 35 degrees. This is alternate angles. Okay, in triangle ABC, AB greater than ACB, this is 75 and this is 35. So this greater than this, B greater than C. Therefore, AC greater than AB. Finally, I have a remark, okay? The hypotenuse is the longest side in the right angle triangle. Why? Because the hypotenuse is opposite to the right angle, and the right angle is the biggest angle in the right angle triangle. So the hypotenuse also is the longest side in the right angled triangle. Okay. In the right angle triangle, the hypotenuse is the longest side. This is a very important remark. Okay, now let's study the inequality of the triangle. The inequality of the triangle said that in the triangle, the sum of lengths of any two sides in a triangle greater than the third side. What does it mean? By looking to these three sides. Here, 6 plus 10, 16, and 16 is greater than 9. 6 plus 9, 15, and 15 is greater than 10. 10 plus 9, 19, and 19 is greater than 6. So, the sum of measures of any two sides is greater than the third. As we see, I choose here the two smaller sides, 9 and 6, and compared between them. Okay, again, here 9 as we see, and this is 6, and this is 10. By looking to the sum here, 6 and 9, 15, which is greater already by 10. Okay, here in this question, show which of the following groups can be lengths of triangle. Okay, number 1. It's a very easy question. I'm going to choose the two smaller sides, 5 and 7. 5 and 7 are 12. The sum of them is 12. So the sum equal the third side. Those the first triangle is not verified to be sides of triangle. So the numbers can't be lengths of triangle because 5 plus 7 equal 12. Number 2, 4 plus 6 equal 10, and 10 is smaller than 11, so it also can't be sides of triangle. Okay. Number 3, 7 plus 9 equal 16. 16 is greater than 14, so it can be sides of triangle. Okay. Finally, here 8 plus 8, 16, and 16 is smaller than 18, so it can't be sides of a triangle. So it's very easy. I'm going to select the two smaller sides and add them and compare between with the third side. Okay, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh.